when it comes to statistics, it takes longer to write the question than it probably does actually answering it. But here, we've got a tough tree diagram question. Let's go through it. It says a bag contains tokens that each have a single number written on them, being the integers from 1 to 12. There's one token labeled 1, 2 labeled 2, up to 12 labeled 12. Two tokens are randomly taken from the bag using a tree diagram. Find the probability of the numbers on both tokens being neither both prime nor both square. Right. To do a tree diagram, which they want us to do, they haven't done it as a separate part, or I haven't when I wrote the question. We need to calculate how many tokens there are. All right. So how many are there? There's 1 with the number 1, there's 2 with the number 2, 3 with the number 3, etc. So we need to add up all of these. This is an arithmetic sequence. Never thought that would appear in a question like this. In fact, let's do this not as part A. It's just like the bits and bobs we have to do before we even answer part A. So we have one token labeled 1, 2 with 2, 3 with 3, 4 with 4, all the way up to 12. There's 12 terms here. You could use n over 2 2a plus n minus 1d, or we could use the easier a plus l. So that total is going to be 12 over 2 times 1 plus 12, which is 6 times 13, 78. So we have 78 tokens. Now, based on what they're talking about prime squares, even if we read on, they're talking about like primes and squares. We're going to have to work out specifically the primes and squares. We should also consider the numbers being neither. Okay, so I think the tree diagram, or my tree diagram, is going to have 3 branches. They haven't indicated to us how they want the tree diagram to look, so it's up to us. And I feel like doing it like this way is probably the easiest, but let me know how you guys would have done it. So what are our primes? So our primes are 2, 3, 5, 7, and 11. We need to add those up. So adding those up, we have what? 5, 10, 18, 28. Then for our squares, we have 1, 4, 9. So when we add those up, we get what? 14. So my neither is, well, I don't even need to know what they are. 28 plus 14, and then we're doing 78 minus answer, 36. All right, now let's look at our branches. I feel like doing a big tree diagram here will be better for us, then we can start doing our working over here. So let's clearly see what's going on here. 1, 2, 3. Then we have 2 takes. 1, 2, 3. 1, 2, 3. 1, 2, 3. Sounds like we're in the army. So we have primes, squares, neither. Primes, squares, neither. Primes, squares, neither. PSN. I'm not going to simplify anything, so the probability of choosing a prime on the first take is 28 out of 78. I'm just going to start doing these already. So if I take a prime, I'm going to have 27 out of 77. For the squares, I have 14 out of 78. So if I take a square, there'll be 13 out of 77. If I take a neither, that'll be 36 out of 78. If I take that, I'll then have 35 out of 77. So if I take that prime, there'll still be the 14 and the 36 for the neither out of 77. If I take a square, there'll still be the same number of primes, 28 and 36 out of 77. Remember guys, in the exam, utilize as much space. They give you tons of paper. So we take a neither, there'll still be the same number of primes and squares. Okay, now let's take a look at part A. So find the probability that the numbers on both tokens are neither prime or square, both of them. So in both tokens, you're not allowed to have neither both prime or both square. Now, if you look at the tree diagram, have a think about which options we want. So you're not allowed to have both of the tokens being prime or square. So if I draw, you know, the kind of options, I basically do not want this. Okay? So basically these two, I don't want those, which means I want PS, PN, SS, oh no, not SS, SP, SN, etc. Actually, you could have all of these options, right? The quickest way of doing this then is not by considering the options that we definitely want. We can actually look at the two options that we don't want and subtract from one, okay? So the probability of PP would be 28 times 27 over 78 times 77. And for SS, we have 14 times 13 over 78 times 77. Okay, so should we just add them and 1 minus? Just do it at the same time. I mean, these have the same denominator. You can actually just write that on the numerator. 1 minus, bracket, 28 times 27 plus 14 times 13 over 78 times 77. I get 362 over 429. 362 over 429. I'm happy with that. Part B. So find the probability that the number on one of the tokens is prime, given the number on both tokens is neither both prime nor both square. Okay, so we have a given statement. We should probably write this out as our normal given statement. So we're saying, what's the probability of a prime? So what's the probability of getting one of them being prime, given neither both prime nor both square? Okay? So that's what we want. I guess we just go about the standard procedure and just change it into an AND statement. And then it's going to be over this probability. Okay? Now just for space, I don't think we need this anymore because we've written it. So we want the probability of 1 prime, given the situation that we actually had in part A. We worked out the probability that neither were both prime nor both square. So this becomes the probability of 1 prime. So it becomes an AND, neither, both. I'm just going to say PP or SS. All over the probability of neither, both, PP or both square. What does it mean to have 1 prime and neither, both PP or SS? So basically, we just don't want these two options. And we just want the options where you have 1 prime. So you could have PS. PS is all good. You could have PN. You could have SP. SN, not good enough. There's not 1 prime there. We could have NP. And that's it. There's 4 options. Let's just write them down. So you could have the probability of PS and the probability of PN and the probability of SP and the probability of NP. All over this probability, which we know is 362 divided by 429. Now what's interesting about this is that PS and SP are the same. And PN and NP are the same. So what we can do is we can work out the probability of PS, double it, work out the probability of PN, double it. Yeah, they're the same outcome, just in different orders. Okay, so they're the same. So I'm going to do 2 lots of, so in my calculator I'm going to do 2 lots of, so we have this 362 over 429. The probability of PS, which is 28 over 78 times 14 over 77. So 28, I'm going to show you guys an even easier way you could compute this. 28 over 78 times 14 over 77. And what was the other one? PN. This times that. Plus 28 over 78 times 36 over 77. Now, how could you have computed this even easier? What you could have said is, because we want 1p, we basically just want this branch excluding that. So you can add these together and say that's 50, 36 plus 14 is 50 over 77. So you can actually do 28 over 78 times 50 over 77, and that will be this really easy. You can actually see it from here. If you factorize out 28 over 78, you're left with this plus this, which is 50 over 77. Which is what I'm going to type in my calculator. So I'm going to do 2 lots of 2 times fraction bracket 28 over 78 times 50 over 77, all divided by fraction 362 over 429. 100 over 181. There we go. Finally, find the probability that the number on the first token is prime, given the number on both tokens is neither both prime nor both square. Okay, so we basically want the same as this, but here we just said 1 prime. So as long as we had p in it, it's all good. Here they're saying, now we want the first token to be prime, which means you can only have these 2 options. Forget about those. Which just means then it's half of this answer. Half the number of outcomes, half the answer, which means we have a really simple solution there. I think that's worthy considering the intensity of this question. The actual maths is not that bad, right? It's actually reading it and deciding, okay, what do they even want us to do here? So the answer there is just 50 over 181. And that's your answer. So it is a tricky question, guys. The wording is very interesting, which is what makes it difficult. But guys, if you learned something today, I'd appreciate if you hit the like button, subscribe for more maths content. If you're interested in my A-level maths courses, more details are in the description. And feel free to join the Learn Gang Reddit page if you want to submit your own questions and get feedback from the community. I'll see you guys in the next video. Nice one, Mike.